Good afternoon, everybody, and thank you for joining us to the demo day of the second cohort of the 5G Studio collaboration between NewLab and Verizon. Today, we have for you 7 companies who would present their results after piloting at NewLab in the months of May and June. We're very excited about the upcoming result and the things you're about to see. Quick housekeeping before we get started. There is a Q&A button at the bottom. Please feel free to submit any questions that you have for the teams, and they'll take the time to respond to those questions once their short presentation ends. You're expected to hear from each team for about 4 or 5 minutes, and then it would follow up with a couple of minutes of Q&A that you guys, as I said, are welcome to submit. And I'm happy to get started. I'll hand it off to Satish, NewLab Chief Product Officer, who will take us through the companies and introduction on NewLab and Verizon.
Thanks, Amri. And so this is Satish Rao, I'm NewLab's Chief Product Officer. Just a few words about NewLab, and you can go to the next slide, Cody. Yeah, so at NewLab, we are basically a center of entrepreneurship and innovation and advanced technology. The core of what we do is oftentimes helping early stage technology companies grow, while at the same time working with a variety of industry and government partners to solve their challenges and accelerate their growth strategies where innovation can be a really key player. And so we do the former by establishing a community of frontier tech startups that are mostly housed in our 84,000 square foot facility here in Brooklyn, New York. And the latter through our studio programs, which we'll talk a bit more right now, especially with our partnership with Verizon. One of the core things that we do in terms of being able to enable the growth of our early stage tech companies is the ability to test and pilot. And so oftentimes at NewLab, using our on-site prototyping facilities and access to our space, including the surrounding 300-acre Brooklyn Navy Yard industrial campus, allows companies to build their first products and really test them in real-world environments. And this is really, really unique, especially for the 5G studio here with our great partners at Verizon. In addition to providing the insights and engagement through a variety of engineers and technical and business experts on the Verizon side, they've also installed a private 5G infrastructure here at NewLab with both coverage inside and outside of our building. And what this has enabled are companies like the ones you'll hear from today to really test what a 5G integration of their products would look like. What would it look like to really compete on the edge? And ultimately, what does that mean for their business case? How does it change their use case today? What does it mean for the roadmap down the road? Does it open new marketplaces for them if they're able to really implement and take advantage of all the advantages that 5G offers? And so this has been the model of the 5G studio, where we have a vision around certain areas of interest and focus areas within categories such as industrial automation, sustainability, energy and efficiency, and transportation. And we say to the world that if you're a company with a great platform that's trying to work in these spaces, how can 5G really enable a new way of looking at that product? How can it really open doors into a new set of customers, and how can it create more cost efficiencies and scale for you as you're trying to build your products as founders and product leaders in your startups? And so this is what we aim to test today, and we've had a great run so far. We started our partnership with Verizon's new business incubation team all of last year, and we're able to create a great set of cohorts last fall, coming into this year with another great set of companies that you're going to hear about today. And so before we get started, I'd love to turn to the head of the new business incubation team, Elise Neil, to share a bit more about their view on 5G edge computing in the sectors that they're working in today.
Hi, everyone. Thanks for the introduction, Satish, and it's lovely to be a part of our webinar today. I'm Elise Neil and have the pleasure of managing new business incubation at Verizon. And I wanted to kick off with just a little bit of an overview for those who aren't familiar with 5G. Kind of why are we excited? What are we talking about? Verizon was first in the world to 5G. And the reason that we're so excited about it is we see it as an opportunity to help shape societies. The ways that we live, work, and play will all be significantly impacted by this 5G future. And our partnership with NewLab and the ways that we have engaged help us to really develop this up and coming new ecosystem, these new sets of opportunities and use cases that help 5G apply to impact those societal kind of benefits that we talked about. And so in this partnership, and as you'll hear through the cohorts today, we really lean on NewLab as a critical partner to help us kind of engage with the ecosystem, to test the boundaries of 5G alongside up and coming startups who are beginning to kind of think about their plays and their opportunities for the future, for us to equip them and to work together and ultimately to learn together. So just a little bit about 5G for those who aren't familiar. If you think about the previous generations of 5G, 1G all the way to 4G, those advancements happened in really just two areas or two currencies. In each iteration, 1 through 4, you only saw advancements in speed and throughput. The speed got faster and the pipe got fatter. The fundamental difference in 5G is that in addition to blazing fast speeds and the fattest pipe we've ever participated in as a part of a cellular network, you also get 6 additional inherent benefits that are built into the 5G spectrum. This is not just another G, it's not just another generation. It is a fundamentally different type of spectrum and currency offering than anything that we've ever experienced before. And so what you see is we've kind of evaluated in these 3 sectors for this current cohort, you'll see opportunities as we look at ultra low latency, as we look at sub 10 milliseconds of latency, we look at ultra reliability. We're going to talk a little bit about energy efficiency and some of those opportunities that are already built into the spectrum. We have an opportunity to connect millions of devices per square kilometer. For reference, today, on a 4G LTE network, we can connect 1,000 devices per square kilometer. That moves to 1 million devices per square kilometer in a 5G world. As we look at mobility, today, we think about in a 5G world, the opportunity to connect and to maintain that sticky connection, to not have a dropped connection at 350 miles per hour or 500 kilometers per hour. The advancements here as we think about each of these opportunities is what ultimately gets us so excited. And so how does that apply to the work that we're doing inside of New Business Incubation? My team has the pleasure of working every single day to build the new software businesses that will participate and help to elevate the 5G future. And so today, those investments are in a wide range of technologies, from aerial and terrestrial robotics, location technology, digital twinning and simulation, energy work, as we look at adaptive manufacturing, and a wide variety of other kind of distributed investments that we're making. The entire mission of our team is to really help to propel and to develop this new 5G ecosystem. So my team is a mix of mostly engineers and product individuals with go-to-market expertise and all of those components all fixed together. I think I have the pleasure of working with the best and brightest and some of the most exciting individuals inside of Verizon. And that pairing of our talent and team and strategy with this new startup ecosystem, with New Lab helping to be the glue, is one of the things that I'm most excited about. So with that, I won't take any more time. Satish, I'll turn it back to you to introduce our exciting group of Cohort.
Thank you, Elise. I really appreciate that. And I'll say that in addition to being able to work with these exciting companies, it's also been really refreshing and great to work with Elise and her team, especially seeing their point of view in these industries. And we're going to hear more about that from Elise at the end of the session. So thanks for that, Elise. And so just a quick view of the agenda. We're going to go through each company. They're going to have a chance to present. Please don't forget about the Q&A. Feel free to submit questions. We'll have a few minutes after each presentation to pose a few questions to the companies. At the end, we're going to do a quick moderated session with Elise and the companies as well. And again, additional opportunities to take questions from the audience. And so to kick off, we're going to start with Ryan Musil at Phantasmo.
Hey there. Thanks, Satish, for the intro. And I'd like to thank Verizon and New Lab for allowing this opportunity to integrate with the 5G infrastructure. It's certainly been a great learning experience, and we're really excited to be a part of it. So at Phantasmo, we're creating a digital interface to the physical world. And in doing so, we've created an end-to-end platform for digital twins, hyper-accurate positioning, and semantic perception. It's all based off of computer vision. And today we have customers operating in North America, Europe, spanning several industries, including micromobility, like the e-scooter you see here, visually impaired navigation, augmented reality, and autonomous robotics. So all these applications share a fundamental need in that they have to have real-time spatial awareness to operate. And that's where 5G can come in and really unlock new capabilities. And for this pilot, we chose to focus on the micromobility use case. So as this proof of concept, we wanted to be able to track an e-scooter as it rode through micro geofences. And we wanted to do so by streaming images from a low-end commodity camera up to Verizon's mobile edge compute. The reason to track e-scooters is to enforce municipal compliance. So things like parking validation, preventing sidewalk riding, and you can see this all across the news in Europe and North America, and cities are really looking for ways to solve this problem. Phantasmo is working with several micromobility operators today to help resolve that. One of the things that is challenging there are capital intensive requirements to putting edge compute and storage onto these low cost vehicles. And so if we can do it over 5G, that can really solve a huge pain point for both the cities and the operators. And then to enable this experience that we were doing through the pilot at NewLab, we also used our mobile LiDAR mapping system to build a digital twin of NewLab. You can see a small render here on the bottom left. And that's what we were positioning off of. Next, please. Thank you. So here you can see us testing the system by riding a e-scooter vehicle that just has a cheap commodity camera. It's actually the Raspberry Pi camera attached to the front of it. It's streaming images up to the mech, and through that, we're able to detect what zones it's moving through as it goes from parking to the street to the road. And these are analogous to what you might see in a condensed urban environment. And what was great from this is that we were able to get low latency response to know when the vehicle's moving between these zones, which is necessary because you want to enact the compliance measures very quickly. And so, 5G, the practical implication is that you get this higher throughput and this lower latency, but the true value is in the flexibility of where you can put your compute and where you can put the data. And that can really ease restrictions on what hardware you have to have on the edge device, cost constraints, and these other issues that operators run into when they're trying to deploy into the field. So where we're at today is that Phantasmo, we're actively scaling with customers across Europe, North America, really focused on the micromobility use case today, but also looking at applications in robotics, HMDs, accessibility, and augmented reality. We have a new product that's coming out here shortly for fully embedded positioning and map data. And really this product we're bringing to market because we don't have access to 5G everywhere yet. So we're having to fill the gap a little bit from a product perspective, but this expands all the way into semantic navigation, perception, autonomous capabilities. And we really see 5G as a critical component in the evolution of our product because we want to be able to aggregate the data coming off of all of these disparate devices and platforms and sensors into a real-time self-updating digital twin.
Awesome, Ryan. Thank you for that. So I think I've got a this question I think is perfect for you. How do you I feel like when we redefine the word infrastructure in future sectors, it seems like location, of course, is part of the infrastructure of what the future of a variety of things will be. And so why is it important for you, your company, and just your point of view in some of these sectors? Why is it important to think that way?
Yeah, so when you're thinking about spatial applications and spatial awareness, location is that first aspect. You have to know where am I and what's around me. And so bringing in location and embedding that into the infrastructure layer is just a requirement for these systems to even operate on top of that data.
Got it. And do you find yourself with Apple, what are the near-term use cases, more outdoor urban environments or indoor facilities like we simulated at NewLab? Where do you see the near-term applications for Phantasmo?
The most near-term for us is outdoors and urban environments where GPS fails quite short. So our visual positioning solution can work indoors or outdoors, but we see a lot more traction outdoors today. And simply, I think it's because, like connectivity such as what we have in NewLab doesn't exist in many indoor environments. And so as that proliferates into more indoor spaces, our technology will follow.
Amazing. Thank you, Ryan. Look, you have a few questions here in the Q&A that I think you can probably type and respond as well, but we'll move on to the next. Thank you. Great. Up next is Ido Gur, the CEO and co-founder of Easy Aerial.
Hey everyone, thank you for having me, and thanks Verizon and ULab for hosting us on this cohort. All right, so Easy Aerial is a neighbor of NewLab. We are actually located here in the Brooklyn Navy Yard. I can actually see NewLab from my window. We are 90 people, and what we do is we design and manufacture drone in a box. So drone in a box is a segment of these fully autonomous systems, these rugged plastic cases that are left outside unattended for a long period of time. So imagine those boxes, spread around the border between countries, or spread around bases, security. And every time there is a need, they open up, a drone takes off, flies around, does its mission, and then come back, lands by itself, recharge itself, and then goes again. Kind of like iRobot or iRoomba to clean your house, just for security applications and remote monitoring. And those boxes, one of the most important things is connectivity, because in most cases they are deployed in areas where no one is around. The whole scenario is without pilots. There is no one to fly these things. They fly themselves, and they need to be able to be smart enough and to send video and get results. And we'll show in this presentation how did we use the Mac and the cloud, the 5G connectivity to get real-time, low latency, very reliable information back to the operator. And again, the operator is anywhere around the world in our case. All right, so on the 5G studio, we use the infrastructure that was given to us outside in the parking lot of NewLab. Great infrastructure, worked perfectly and highly reliable. And we, for a week of flying, we did flights every day, and the drone took off, flew around the parking lot, identified in real time people, vehicles, trucks, and we used this super high bandwidth connectivity to have, I would say, near real time, but for every human being, it looked real time, sending the video, high resolution video, optical and thermal, to the Mac, getting all the analytics done and getting the information back, which was in this case bound in boxes. So we didn't need to put any intensive computer on the drone. When you think about working with drones, there's a few ways to do it. You can put a big computer on the drone, which of course takes power and creates heat. It's expensive. But the other way, the 5G way, is to do this HD video transmission in full 5G, optical and thermal, and getting all those advanced AI, machine learning analytics running in the background, using servers that are nowhere to be seen, and getting those, in this case, boundary boxes around the people and the vehicles right to the operator, again, not on site. So this is what we did, and it worked very, very nicely. And in addition, we also integrated with Verizon Skyward, and the location of the drone was shown in real time on their system as well. All right, so this is our system, in this case on a pickup truck. As I mentioned, it's a relatively small pickup plastic case. We separated here a trigger, and a trigger could be a fence alarm, a seismic alarm, doesn't matter which one. And the drone takes off by itself, in this case flies around the parking lot, identifying people and cars using the analytics that is running on the Mac. And then the drone comes back and lands by itself inside the ground station. So this is, for our use case, Easy Aerial, it's very, very important, because all of our products assume that there is no operator, there is no persons on site. These plastic cases, these ground stations, are left unattended for weeks and months already with our DoD customers on borders and basic security. So to enable them to run advanced analytics is a key feature of our offering. So what's next? We have these boxes spread around the world. We now have systems in 10 countries, but we just started, right? But we see that, in the near future, there will be thousands, tens of thousands of these boxes, also smaller boxes, bigger boxes, and those robots will activate themselves and fly themselves and really understand the environment around them. And for that, they really need to have good connectivity. So low latency and high reliability are key features of what we need, and that's what we got in this activity. Again, our systems are left outside for a long period of time. They need to be rugged, and it needs to work on all weather. And really, the most important thing is DV loss. All of our systems operate without human intervention on site, so they have to be connected to a highly reliable network. Hopefully it didn't take too much time, and thank you again for having us.
No, that was great. Thank you very much. And it was exciting to see your systems flying around. You're our neighbors here at the Brooklyn Navy Yard, but we didn't get a chance to test with you until now, which has been great. There's actually a nice question from the audience here is, how do you think 5G can help you operate in remote locations? And oftentimes I think you are operating in remote locations, I think, with some of your customers.
Yeah, 100%. So it all depends on availability. And a lot of the areas, we don't have it. Sometimes we actually take off from cars, and the cars will have big antennas. They will have actually their own network as a mobile network that goes on the vehicle. And in some areas, we just don't have connectivity, and that's an issue. But yeah, this is, we can only enjoy 5G as long as we have it. So if we don't have it, we can enjoy.
Thank you. All right, thank you, Ido. Appreciate the time.
Our pleasure. Thank you so much.
All right, up next is Aaron Fisher, the CEO and co-founder of EV Passport.
Thank you, Satish. And thank you to the Verizon and the Nulab team for working with us on this pilot. So EV Passport is an electric vehicle hardware and software platform provider. We pride ourselves on being the only platform out there with a completely open API, which allows us to do really unique things and build solutions ad hoc and not necessarily silo ourselves into concrete product offerings. So for this pilot, what we did is we actually took our standard Ezra electric vehicle charger and added both 5G to it, and took our software and operated it on edge computing locally at Nulab in the Brooklyn Navy Yard. And for this, we actually used multiple Tesla yellow taxi cabs to demonstrate two different areas, both 5G latency reduction and the ability to operate a smart connected charging network on edge computing with, let's just say, a natural disaster were to occur, and the ability for a network to stay online, or at least batch transactions and occur as much offline as possible. Now, normally, all of our electric vehicle chargers operate on LTE. So being able to operate on 5G greatly reduced latency. When we go and install a lot of electric vehicle chargers in a very dense urban environment, let's say we're installing 10, 20, 30 chargers, and then you layer on all the other LTE devices on top of that, you can end up with a massive amount of latency. So moving over to 5G for this pilot allowed us to greatly reduce that latency. And then we moved our entire charging management system from the cloud, which runs on AWS, to the Mac locally at Nulab. And that actually reduced user activation, which is the start of a charging session, by 50%. And it increased the frequency of data coming from a charger. Normally, we will receive data every few seconds from a charger, and that will communicate with our cloud. And that's used for things like load balancing, charging the amount for the driver. And by actually having that come every few milliseconds, it gives us the ability to adjust, especially when it comes to smart grids. And then reducing the latency allowed us to end the charging session nearly instantaneously, which benefits the user, benefits the grid, benefits our infrastructure, and really is just a much better experience. Here's a neat little video of us pulling in one of 5 Tesla yellow taxi cabs in New York City. And so the MEC provided noticeable gains in speed and user experience, and it also provided better stability and resilience for our infrastructure. And so in the past on LTE, when you have a massive number of chargers, you end up getting that latency. And you end up with the result being delays in data coming into our servers when it comes to logging, which can create issues. Using 5G and the MEC to reduce the latency across the board helped us increase the ability to monitor our infrastructure. So both combined, absolutely amazing. Even just using the MEC or just using 5G is a great improvement. So it reduces the connection points and therefore reduces the possibility for error. So in the next few years, EV Passport is deploying thousands of chargers across North America. Right now we operate in the US and Canada, and that's across hospitality, commercial real estate, multi-unit developments, universities, sports stadiums, you name it. Everywhere there is not a charger, we view as opportunity space. And by providing a more integrated user experience, whether it's plug and charge or out-of-the-box QR code with Apple Pay or Google Pay, or integrations with parking reservation systems or university systems, that's where we're headed in the next few years. So integrated charging for plug and charge is the holy grail. And one component that is absolutely needed for that is speed and reliability. So 5G and edge computing helps with that, especially as we introduce, which we just put live last week, our new Howard charger, which is a 19 kilowatt level 2 charger, which is great for hospitality, retail, and fleet. So in the pilot at New Lab, we used a 7 kilowatt Ezra charger, but if we were to use a 19 kilowatt charger, those Teslas would be getting about 70 to 80 miles of range per hour, potentially with plug and charge, all operated over 5G and edge computing. And that data quality and reliability is absolutely key for our monitoring of our infrastructure and not just the user interaction. The more fail-safes that we can put, the better it will be an experience, not just for us as a company, but also the driver. It should be better than getting gas, not the same and certainly not worse.
Cool. Thanks, Aaron. And I'm going to combine my question with one that came in from the audience. Certainly, a lot of this is based on the adoption from the consumer side and moving to EV, but it seems like your interoperability is certainly speaking to the infrastructure managers, right? The apartment building managers, the folks in the public sector. And so question to you is how should we think about that when it comes to the EV Passport product? And then what are certain metrics that you're seeing from the customers on that side that you need to kind of hit?
Absolutely. So our customers day to day are owner operators. They are the building management companies. They are the tenant access systems that are installing chargers for their customers, which are drivers. And so when it comes to increasing utilization of those chargers, we view integrations and customer experience as essential. So while our customer is the building operator, our ultimate customer is their customer. And so when a driver can see a charger on Google Maps, they're more likely to use it. When a driver can see a charger on Apple Maps, wherever they might go to discover the world, they're more likely to use it and increase the utilization rate, which ultimately benefits our customer, which is owner operators.
So it sounds like utilization and experience, customer experience of their customers sounds like the key metrics for you there.
Absolutely. The average utilization for a level 2 charger in, say, a multi-unit development is about 30%. So you're looking at 8 hours a day of usage.
Got it. Great. Well, thank you, Aaron, and I appreciate the time.
Thank you.
All right, up next is Apurva Kiran, CTO and co-founder of Itradlab.
Thanks, Satish. Hello, everyone. Thank you for having me as a part of 5G program. Itradlab is an IoT company that has a connected workforce platform leveraging smartwatch and computer vision for factory floor operations. We use smartwatch for collecting the micro data related to your workforce, and then computer vision for macro data on the factory floor operations. We digitize these data to give you insights on workforce productivity, safety, etc. When we came to 5G Lab, we had 4 different kind of challenges, and they were related to stability of network, latency issue, installation cost, and high cloud cost, and that's what we addressed. Here are the 4 goals that we achieved during this pilot. We leveraged 5G for improving the network stability and latency issue. And we were also able to use MEC for reducing our cloud cost and reduce the latency issue. This is a video demonstrating how we use our system. We have a gateway installed on the factory floor, which collects the data from all the smartwatch as well as camera. We collect that data, push into the cloud, and then we analyze those data to give you insights on safety and productivity. As a part of Verizon 5G Lab, we implemented a local software that did edge computing of all the data collected from the workforce and sensors, and then push that data to the cloud to give you insights in real time. We were able to reduce latency, and we were also able to reduce the cloud cost. Both we were able to reduce respectively by 30% and 40%. This also simplified our software architecture that resulted in simpler installation time. This is what we focus to develop in next few years. We want to allow our customers to use our system to make informed decisions faster, quicker. And then we want to be the single truth of source of truth and control in the factory operations. Cybersecurity is going to be another thing which will be key focus during this time. We also learned that there are evolving requirements for 5G installations, so we will focus on that part as well. Overall, 5G has helped us in collecting and managing large amount of data from the factory floor. It also helped us in lowering the cost of installations. Our onboarding experience of customers is will improve as a result of 5G, and we also hope to improve the security of our software.
Amazing. Thank you, Apurva. So a quick question for you is, as I feel that you're likely operating in industries that you might consider to be legacy, and using data in any kind of way like this is something new. So how do you convince leaders or managers of plants and manufacturing sites to use this data in this way when managing their workforce?
There are 2-3 reasons which have helped us in recent times. So during COVID, when all the factories got shut down because of workforce related challenges, we see a faster adoption because of this new situation. Overall, our customers are divided in 4 verticals. 2 of them I will say are laggards. So for example, food processing company and metal fabrication, they are slow to adopt, but there are other segments of industry, for example, automobile and electronic manufacturing, who are faster to adopt. In our experience, there are 2 things which can help faster adoption. One is helping the customer to come up with a better ROI. If you have a good IT product that convinces the customers that you have up to 10x ROI, then they're willing to bet on the platform. And the second one is IT related. IT is always preventing you from getting into the factory. If you come up with a good onboarding experience, easier installation process, then it becomes easier to adopt for the customers. Understanding the org chart is very important. So a lot of time understanding who makes the decision in the factory, how they make the decision, helps us to get our platform adopted easily. Did I answer your question, Satish?
No, that sounds great. Thank you. Well, thanks for the time. We'll have more time perhaps to speak with you later at the end of the session. So thank you.
Sure. Thanks, Satish.
All right, up next is Sven Mesaki, CEO and founder of Sojourn.
Hi, Satish. And like the other cohort members, thanks again for hosting us at New Lab, and thanks a lot to Verizon for the opportunity to work on this equipment and connectivity. So at Sojourn, we provide a proprietary computer vision system, and it works to enable better delivery at those last steps of the last mile, down to a centimeter of accuracy. And this improves deliveries into people's homes, their businesses, or any on-demand real-time location. We don't require any additional hardware. We utilize the sensors that are already on devices, whether it's a mobile phone or a robotic device. So our goals moving in, we wanted to look at reducing latency when we are in a delivery mission, whether it's robotic or human. Latency can really provide that jitter that is going to, limit the customer experience. And we're looking for real-time control, really snappy, quick deliveries. As well, improving the load balancing. We don't need to store everything up on the cloud when we have a geographical domain, and it makes sense to keep that data local. Additionally, we wanted to look at responsible use of blockchaining to manage these massive groups of map data that create different pinpoints within customer environments. And with in this project, we used a drone, and we wanted to be able to observe the ability of a drone to react to changes in a pinpoint in a delivery mission. And again, looking for that low latency and reduction in jitter. So we been a cloud-based service, and we took our entire cloud platform and moved the server core onto the edge with absolutely no connectivity outside, no more cloud. Happy to report that that was successful. The MEC means that, as these new topologies emerge, these new ways of businesses keeping their data here and there, having this early access to the MEC allowed us to verify that we are good to go there. And the blockchain genesis that we created, we'll continue to work with that through the year so that we can better manage as, the network effect of massive amounts of map data becomes stored upon the MEC, that we can look at using that local compute resource to improve our overall system. All right, so what's up next? So we really see the smart home as a place where our technology can be incredibly useful. Right now, it's about the mobile device in your hand or the robotic or human courier. Now, the devices within our homes already, smart cameras, robotic vacuums, and who knows what's next. We're looking to very keenly integrate within there, become easy to use so that this data can be managed better, meaning a much better customer experience, very hands-off. Additionally, digital twinning is going to be important, as a lot of decisions about delivery missions can be made in advance with solid digital twins. And as the supply chain can be visualized, we not only get cost savings, but also better outcomes. And as far as 5G, the latency that we experienced was one thing, but the real time of data moving back and forth, we saw a 40+% improvement using the edge versus the MEC. And that's a huge increase in not only in economy, but also in efficiency. We believe with additional development, we're going to see that potentially develop into a doubling.
Awesome, thanks, Sven. It was great to. I was here at New Lab when you did that one of those last rounds of tests. It was great to see the drone sort of find that location so quickly. It was pretty cool to see that. There's a question from the audience. I think is a good one. Is how do you see your platform integrating with robots and AMRs? You can pick the sector. Maybe it's in the home or maybe it's in the factory environment. Okay, so in the case of this demonstration, we used an off-the-shelf demo, an off-the-shelf drone. We are developing also within New Lab for the open source, which is key to the drone industry. A lot of these workforce drones or also wheeled robotics are utilizing open source, which has been a win in multiple industries. We kind of see it as the red hat of delivery by robotics. So the ideal pathway for us is to continue to participate in open source. We are a member of Drone Code, which manages the open source platforms. So that's our key angle to work into there. We're also open to working directly with drone manufacturers. But again, the best way I've found in my career has been through open source. And in that theme, that same regard, are you looking at interoperability? And there's another question from the audience, interoperability with AR/VR platforms. And if so, what are the challenges you kind of see there?
Sure. We think AR is huge. The background of my career was recently heavily influenced by augmented reality. This is spatial recognition. So the data that we collect, the graph files, the maps that you see on a phone screen are also just a few clicks away in a game engine from being an augmented reality or virtual reality application.
Great. Thank you, Sven.
Thanks, Satish.
Okay, we have next is Robert Topol, CEO and founder of Electron.
Hi, thank you very much for having us and letting us participate in the Verizon 5G studio. I'm Robert Topol, founder of Electron. We're located in Hillsboro, Oregon, and our focus is really full stack robotic manufacturing platform that enables companies to scale and be competitive in high mix, low volume manufacturing. Some of the challenges that we've seen in this industry are the time it takes to program, and that's one of our focuses, as well as could we program the robot remotely. So our goals for the studio were, could we program remotely or modify programs remotely? What were the issues around that? Being able to provide remote supervision. Could we stop and pause the robot in a timely manner? Could we enable commands of the robot? And could we get the camera fidelity to the level that we really need to get to a safe system? And we really had some nice outcomes. So when we did the testing, one of the things that we looked at was, could we get a visual response good enough to be able to program the robot or manipulate the program at the levels that we need? And the kind of things that we're doing require sub-millimeter performances. So in the video, you can see the cameras are pretty focused and they're pretty high resolution cameras. So could we do that? Could we see the situational awareness? And could we have the cameras provide the fidelity? Could we run the robot in a remote mode and have it operate, be able to stop, be able to start, etc. We really learned a lot in terms of how the robot performs, where the latencies are, and some really surprising results. We weren't surprised on the low latency. That was kind of a given. But one of the surprises that we saw was in our testing was really what we call low variance. So if you have the robot operating in a wireless environment, we would get consistent numbers, in terms of the response time. And we were really shooting for things less than 250 milliseconds. 200 milliseconds is a blink of the eye. So we need, they're pretty big, but we would see situations where the normal variance would be, we were seeing, 10, 15, 25 milliseconds on a Wi-Fi and spike up to 200 milliseconds. And in the chain, that becomes very critical. So we were very pleased with not only the low latency of the 5G network, but also the low variability in that. It also points out areas that we need to improve our system in that chain. So for example, if we're sending a command to stop the robot, the command is sent very quickly and very reliably. The robot then operates on that command and responds, but its first task is to shut that robot down. So it may take another 200 milliseconds for that process to take place and then report back. But we could do something where we're going to modify the system to say, yes, we've received the command and we're shutting down, and so that the mobile edge computing can know what's going on. So in terms of our objectives, we were pretty excited about that. So for the future, one of the things I think we have a future slide there. Whoops. For our future endeavors, we are continuing our development for the robot to what we call Block 3 or Proton 3. And in this particular case, we're really integrating AI in every aspect of the robot, both internally and externally. And this is where the MEC is important, because even though we may have onboard AI, we've got to train those networks and update those networks. It's pretty straightforward with one or two robots, but as we scale, it becomes a real challenge. So our focus in the short term is to take the robot with Block 3, continue our customers out, our base customers and our beta sites, and then expand into the enterprise with 1 to 2 enterprise companies. Now, our initial focus was high mix, low volume for small companies, but with 5G, that enables us to really be able to support enterprise level and to support Factory 4.0. This enables us to do robot as a service, really changing the factor for manufacturing. You know, there's 250,000 US manufacturers in the United States. 70% of those are under 100 employees. So they really need to be able to switch fixed costs into variable costs, and robot as a service enables that. And looking at 5G and the ability to have the MEC support, we can really scale that up for enterprise level. So the 5G as part of our development roadmap is now going to be integrated pretty much throughout the system as part of what we do, not just for the robot, but for the ancillary support function.
Awesome, Robert. Thank you. A quick question from the audience is, you know, I'm going to ask it differently. How do you look at robots interacting with each other within a warehouse or factory environment when you look at your product?
Say that again, I'm sorry.
How do you look at, you know, the way you're implementing 5G and edge compute and some of the other advances you're making? How does that impact the way the robots can work together? Let's say a field of them in a warehouse or a factory.
That's a very good point. And so one of the things that we are participating in is IPC's Factory 4.0 implementation plan, CFX. And the idea is that the equipment communicates with each other. Part of Factory 4.0 is that you don't just have equipment that reports up or does, you know, ERP reporting, but it actually communicates. In other words, the robot arm might transfer something to another robot. Well, it says, I'm ready to go anytime you are. You can use a number of protocols to do that. The more we can do that with open source, the more we can do that with things like very fast, low latency networks, means there's less wiring, less costs, less implementation, and faster times to getting the systems up and running. So we really see that as important. It also enables us to do things like mount a robot arm on a mobile platform, or a number of different kinds of applications in warehouses and those kinds of things, and bring precision of this type of robot to the local thing. So the Factory 4.0 not only enables machine-to-machine communication, but we believe that will greatly enhance the ERP implementation of data transfer back to the system in a meaningful way.
Oh, that makes sense. Cool. Well, thank you. It was fun. I'm looking at the robot right now, right at the window. So I look forward to seeing the demonstrations later in the week.
Thank you.
Thanks, Robert. All right. And our last one, but not least, of course, is John Wheeler, co-founder of Fermata Energy.
Hello, and thank you, Verizon and New Lab. This is a tremendous opportunity, and we had a great time on this project. Fermata Energy is a V2X company, which basically means we take parked EVs and turn them into energy storage assets. We provide the hardware as well as the software platform to do that. And there's a couple of reasons why you'd want to do that. Energy storage is very, very important and valuable to us right now for a number of reasons. One is if we want to transition to renewables like sun and wind, that's not always available. The wind isn't always blowing, the sun isn't always shining, and we need a way to store that energy and use it when we need it. And right now, energy storage, stationary storage, is still very expensive. But if we could use a bunch of EVs to do that, we can bring down the cost of that energy storage as well as the cost of EVs to enable adoption. Another reason is that we are seeing impacts from climate change right now in places like California and more recently in Texas, where having access to backup power is essential, and EVs can provide that as well. In this particular studio, what we wanted to do was understand how 5G can enable this transition from a centralized fossil fuel-based generation system to a distributed energy generation system. And it is well understood that 5G is really essential to connect many different types of distributed energy resources like solar panels, batteries, EVs, HVAC systems. As a whole, 5G is essential for that. And that's well understood with simulations and things like that. But we have the opportunity here to really test an actual physical deployment with observable results in the real world. And one of the things we wanted to test here was latency, because latency is very, very important. If you talk about managing the grid needs to be managed and kept at a certain frequency, and voltage needs to be regulated. And once things are coming on and off the grid, like solar with cloud coverage or people charging and uncharging and unplugging, managing all those assets needs to happen in a very stable way. So what we did is, and which was pretty incredible, and I think a testament to the team at Verizon and NewLab, is in 60 days, we took one of these chargers, which not only charges the vehicle, but discharges it. And we got an interconnect from Con Edison and installed it on the grid. And to do that in less than 2 months is pretty incredible. So this thing right now is powering the NewLab building on the grid, providing power. And not only did we do that, but we put our whole software on the cloud, on the edge, and ran the whole thing in 5G. And the results were pretty great. Like other folks, we basically cut the response time in half, going from 0 to 15 kilowatts in about 100 milliseconds, which is pretty good. And that was with an unoptimized system. I think once the hardware catches up to 5G, we can get that probably below 20. And there you're talking about real-time grid regulation, which opens up a lot of interesting possibilities. So what's next? Well, as we wait for the grid to transition, again, from this, centralized natural gas plants, coal plants, to distributed energy resources on people's homes, in vehicles moving around, as we wait for that to happen, which might take a while, what we're seeing is parts of the grid are kind of being sectioned off in things called microgrids. And that could be anything from powering your home, or in fact, NewLab is actually a microgrid, and they can be larger. And these microgrids can have many different types of resources participating and balancing and providing power in that resilient grid. And being able to harness 5G, to have all those things coordinated in real time, really enables that, particularly the larger ones, because if you didn't have 5G doing that, which provides very low latency, you'd have to have a lot of other equipment and basically capacitance built into that grid. And 5G can basically avoid all that if these systems are going to be connected to the internet through the cloud on 5G anyways. We see that as a near-term potential for this.
Amazing, thanks, John. And so there's a question from the audience: is how do you look at integration with other sources of energy such as solar and wind? I think you mentioned that in terms of a need to be able to manage the power, but what does it look like today for Fermata?
Sure. So the easiest way to explain that is there are places like California and even in the Northeast now that have high penetration of solar. And what's happening is, in the middle of the day, there's lots of sunshine. We're in California, so it's a perfect day every day, as long as there's no forest fires. We may not be using a lot of energy, but there's a lot of sun, and we can be charging our vehicles. We want to charge our vehicles with solar energy. But what happens is, as the sun goes down later in the day, all that energy generation starts coming offline, but people are coming home and they're cooking dinner and they're watching television. They're still using quite a bit of energy. But again, that solar resource is coming offline. So when you drive home, if you could discharge your vehicle to power some of your house or your building, that provides that additional power that's still needed until people go to sleep. And that's the basic application to integrate with solar right now.
Love it. Yeah, makes sense. That's great. Cool. Well, I'd love to get all the panelists to come back on. And I've got a few questions to kick off with Elise in the last 5 minutes that we have here. Great. So we're a little shorter on time, Elise. We had a little more time planned, but I think we had some great discussion here. We want to get some audience questions out. So I'm going to kind of broaden the question to you. Like it was going to be a little sector specific, but I think one theme we're seeing from this cohort is sort of this redefinition of the word infrastructure and what that means for sectors, right? So we have location technologies, we've got sensors and instrumentation for machines and factories. Of course, we've got the energy infrastructure we need to be able to transmit power to our EVs. And so 5G connectivity, edge computing runs all through that. So maybe if you want to pick a sector like manufacturing, but how are you looking at this in terms of an infrastructure plan?
Yeah, I think there's a couple different pieces, and I like the way that you kind of frame that. First, when we think about the application of 5G into every single one of these areas, I would kind of classify them with what we kind of call Industry 4.0. You're looking at manufacturing, logistics, supply chain, energy components, et cetera, kind of all working together to say, how can we participate in this 5G future? When I think about the opportunities, there's infrastructure, which is one part of it, which is both the cellular infrastructure as well as many of these components that we talked about. There's devices, there's hardware, there's other energy infrastructure, et cetera. But then you have kind of the glue that sticks it together, because infrastructure alone isn't enough. And as we've seen today, it's the combination of connectivity, hardware, and software kind of all mixing together. And that's where we see this opportunity, and frankly, why we've been so excited at the output of the participants here in the cohort, because you see this blending and mixing. But when we think about the overall opportunity of Industry 4.0, it comes in 4 areas. There's interconnection. So you heard it in every single person kind of talk about the interconnection of the physical, biological, and digital worlds all kind of coming together. The second is data transparency. There's high degrees and high rates of data transparency that needs to happen, not just one-to-one, but one-to-many in terms of an ecosystem. There's high degrees of technical assistance as we look at the application of ML and AI models to help move from just metering and sensoring into intelligence and predictive and into action sets, et cetera. And then kind of the final piece is distributed decision-making. And I think we've seen that in at least half of the cohorts today, is they're kind of moving where the decisions happen, not only how quickly they happen, but where they happen, from potentially the far cloud to the near cloud to the edge to the cellular edge to the device. And as we think about those distributed constructs, 5G really sits at the middle enablement layer to kind of power each of those components to happen with the right speed, reliability, security, low latency that's required to kind of foster this new ecosystem.
Yeah, I think that's right. I think, Robert, you touched on this as well, at least from the manufacturing standpoint. Some of that looks, I feel like, is getting standardized, especially when you talk about the distributed autonomy or decision-making. Where do you see, is that a near-term thing in that industry when you think about manufacturing, Robert? You should unmute. Robert, can you unmute yourself?
So I totally agree. So one of the things we learned as part of the 5G, we were just beginning our AI venture, and now we see really what we can do with that and how we can use that and embed it even more. And part of the Factory 4.0 is machine-to-machine communication to improve actually what's going on in the process management, right, in manufacturing. So one of the challenges you have with that is you get into sort of the whipsaw effect between, making a decision and how that decision affects the end product, right? And humans are very good at this sort of tribal knowledge that if I change this parameter, it's going to goof something up downstream. But we need the machines to be able to transfer that AI and be able to have that, like you say, that data transparency and that machine communication at a much higher level, and have the AI be able to communicate. And that's what we're really excited about, is how far we can take that.
Cool. Great. And so the last question, Elise, is to you, is we've had a year of great work with a lot of awesome companies. Several of them are here today. These are mature companies. They've raised rounds of capital. Many have products in market. I feel like MBI has a different point of view in terms of how you view partnerships with these early stage companies. And so I want to give you a chance to kind of speak a bit about that and sort of general feedback to the world of entrepreneurs that are out there.
Yeah, well, I'll tell you, we don't have it all right here, and we're learning as we go, but I think the opportunity to work inside of corporate innovation is a delicate one. As we think about both my own personal experience as an entrepreneur and those that we kind of bring on board, I would kind of give guidance in 3 core areas to any entrepreneur that is looking to partner with a major corporate. The first piece of advice I would give is understand what you want. what do you want out of the partnership? Are you looking for a sales channel? Are you looking for technology? Are you looking for NRE? Are you looking for revenue? What is it that you want? And be crystal clear on what you want. The second piece of advice is understand what the corporate wants. Understand what their core strategies are and what they're driving towards. Any corporate is not interested in what might be celebrated in a startup, kind of getting to that unicorn status, typically isn't big enough to matter to a corporate. You actually have to have $1 billion or more of ARR, not just the valuation of $1 billion. And so kind of thinking about what does that corporate want and how do we play into that? And then I think the final piece of advice I would give is articulate why you clearly are the best to provide that and be really clear about whether or not you are the best. I think what we see sometimes is some wishy-washiness, and that's where troubles happen, where a startup doesn't really know themselves and they don't know what they're the best at and they don't know exactly what they want. And so that marriage kind of that has to happen, you know, maybe doesn't happen as quickly as possible. And so it's really about knowing yourself and staying true to what that is and fighting for the things that really matter to your business, to your customers, and to your scaled opportunities, and making sure very early on that you're aligned with that corporate and where they want to take it. I think that will eliminate like 80% of the problems just in terms of alignment, but the opportunity is bright and the 5G future is right around the corner.
Yeah, that's great. I appreciate that. And I feel like testing and being able to work together a bit, and this is a shameless plug for the studio model that we're running here, of course, but I feel like Verizon, the startups and New Lab, we've all sort of appreciated that time together to go work and test and sort of see how each other can bring to the table.
Yeah, you got to try everything on for size. I think that's absolutely right.
Totally. Any other final comments from any of the panelists? No, great. Well, I really appreciate the time. The work has been incredibly exciting. This is not the last you're going to hear from this group. We're going to have some outward social and sort of presentations of the work to date. But thank you everyone for the panelists for the time and definitely the audience for participating. A lot of great questions in the Q&A. And we look forward to getting you guys to join the next session we'll have likely in the fall.
Thanks, everyone.
Thank you so much.